Alright, let's go and take a look at that warm-up. So you guys had to do problems 3, 6, 9, 11, and 13. I'm going to go ahead and show you the answers for 3 and 6 so you can double check those. And see how we did with it. Alright, do we have any questions on 3 or 6?
Can you go through? Can you do
Number 2?
This is the warm-up.
Okay. Are we good with 3 and 6 on our warm-up? Alright, so show me with thumbs how you felt with these two guys. Okay. And then we move on to number 9. So number 9 here, as Bo mentioned, ended up not needing U substitution. So just a reminder, do not force it if it does not work. If you did U substitution, I think some people last class said they let U equal X, which is fine. You're just kind of just rewriting the exact same integral. But we want to rewrite it with our negative exponents there, and then we can just multiply them together and then just integrate like normal. So this was just kind of a reminder, you don't have to do U substitution. When we do U substitution, that's when we have a composition of functions, and we don't really have a composition here. This is just cube root of x, not cube root of like x squared plus 3. So questions on 9? Okay. I'm going to scroll down. So here's 11. I'll show you 11 first. So 11 here, I heard you guys as you were working on this, recognizing, hey, my bounds changed to both being 2. And the second that we have both bounds is 2, so once I have this step here, the 1/2, let's see what I'm going to write today. Maybe if I plugged it in.
Is it okay when we do like the bounds for definite intervals if we just put like the right box in your bracket?
Right box. Oh, you mean like just the right side of the bracket?
Yeah.
Yes, as long as you're integrating everything to the left. The reason why I go into the second bracket is because sometimes we'll have like our initial condition plus that. You want to make sure anytime you have that, you separate that from your integrator. Okay, so once we get to this part where we have both bounds are 2, you do need to write out the integral where both bounds are 2. You can literally just say 0 because there's no width. There's no width to our area, so there's no area to find. If you went ahead and actually plugged in those values, it would have got for 0. Questions on 11?
So you just state like that the U values are you need to write out the
You do need to write the integral because here you're realizing it, but it's the property says that when my integral has the same bounds, that's 0. So you do need to write out the integral that has those same bounds and then to 0. Alright, so then 13. It was just a kind of pretty normal one. It even said it. Oh, it's at the bottom. Okay, so 13, this is a kind of just normal U substitution. So this is what I was talking about, that we are looking to do U substitution when we see that we have a composition of functions. And so this piece here, I can see I have this function inside the quantity squared. And that inside is what I typically choose to be my U. Again, we also talked about last class how I should expect to see the derivative of U represented somewhere. Let's take a look at that and see what we did. right, and do we have any questions on 13? Good. Okay, so go ahead and get out your homework. That was worksheet 3-6. Oh, good. All right, so on our homework, I want to take a look at a few specific ones where you had to do some fancy algebraic footwork. And ideally, we looked at the key and saw what was happening there. All right, so first I want to take a look at number 2 here. Yeah. So number 2 on the indefinite side, you did not have to do u substitution because we could have gone ahead and multiplied this out and gotten then the integral of x plus x squared dx. But you could have done u substitution. Let u equal 1 plus x, du is dx, and then gone from there. If you do u substitution, though, watch what happens. When I go to rewrite my integral, I have that this guy is u, and I have that dx is just du, but my problem is that I still have an x sitting here, and I have to deal with that. I cannot have an integral at any point in time that has both x's and u's in it at the same time. So we can still do u substitution, but you have to do something fancy here. I cannot have x sitting in my integral, but I do have u written in terms of x, so I can rewrite this as u minus 1 equals x. So I just subtracted my 1 over. Does that make sense what I did there? So then x is really just u minus 1, and I can substitute that in, and then I would still have to distribute u squared minus u du, and then integrate from there. So you didn't have to do u substitution. If you did, that's fine, but you would have had to do this kind of extra, what I call back substitution, where you solve for that x variable and substitute it back in. There are certain times that you do have to do that fancy footwork there. It's not often, but they probably will throw in like that at you. Questions on that one with number 2? Okay. So the next one I want to take a look at was number 3 here. Alright, so again, if we rewrite this, I have square root of x to the 3rd, so that'd be the same thing as x to the 3/2, times x to the negative 1/2. Again, I could do u substitution and let u be x to the 1/2. Because if I see this here's my composition of functions, so then I would let u be this inside of square root of x. And then I could go from there. Or I could just simply go ahead and multiply this together here. When I multiply x to the 3/2 times x to the negative 1/2, what do I get? What do I do with my exponents when I multiply them? We add them, right? What's 3/2 plus negative 1/2? Just 1, right? It's 2 over 2, which is just 1. So I really just have x dx, and then that's super quick for me to integrate. So again, you could do u substitution, where you could let u equal x to the 1/2, because that is my inside, and then du would be 1/2 x to the negative 1/2 dx, and go from there. But rewriting it and multiplying it actually is a lot faster, of course. So if we take a look at the answer key for number 3, they had a different answer than x squared over 2 plus c. So let me pull it up real quick for you. For number 3 here, we can see that when they did u substitution, they got this for their answer. So square root of x to the 4th power. Well, again, square root of x to the 4th power is just x to the 1/2 to the 4th power. And what's x to the 1/2 to the 4th? X squared. Good. So then our answer ended up being just x squared over 2 plus c, which is what we had here. So even though they look different, they actually end up being the same answer. Yes?
So we have to write it like that, or is the other way also?
The other way is perfectly fine. Yep. Having that squared root simplifies down to the same thing, so for your spots, please. Yes?
Can you just go back up to 2 really quickly? I'm confused because if you don't use substitution, I think someone did that. Wouldn't it be x squared over 2 plus x cubed over 3 plus c? But then if you do the substitution, it gets x cubed minus 2 over 2 minus x squared over 2.
So let's
Or
see.
over 3.
So u squared ends up when we anti-differentiate this, we have u cubed over 3 minus u squared over 3, right? And then we have to substitute this back in. So I have 1 plus x quantity cubed over 3 minus 1 plus x quantity squared over 3 plus c. And if we were to multiply this out and simplify it, we end up getting back up to here. It should result back up to the same thing. That was supposed to be a 2, wasn't it? It should, in the end, result in the same thing. Alright, the other one that I want to take a look at was number 9. That's where it starts to get really crazy. So, number 9 here, again, we see that it is a composition of functions. And so we want u to be that inside piece, that inside portion of my composition. So I'm going to let u equal 1 plus x squared. And so du is 2x dx. Now the issue with this guy is that when I go to rewrite my integral, I have square root of u, or u to the 1/2. But then this piece here is x to the 5th dx. And all I have is just an x dx. So this is where we end up having to do back substitution again. Okay? So let me rewrite this here. If I were to go ahead and rewrite this, I have x dx, right? That's what I have. So I have square root of 1 plus x squared. Now x to the 5th, since I have an x dx, I'm going to go and break this up into x to the 4th times x dx. Because I have this piece taken care of with my u substitution. You guys good back there? I don't know, Gabe's still talking again? Okay, good. And I have x dx taken care of with my du substitution. But the problem is that I need to deal with this x to the 4th. You do with that guy there. So doing back substitution, I can go ahead and solve here. If u equals 1 plus x squared, then u minus 1 equals x squared. Are we good with what I just did there in blue? But I don't need x squared, I need x to the 4th. So let's go and square both sides. So u minus 1 quantity squared would be x to the 4th. Does that make sense there, what just happened? Now I have all the pieces necessary to rewrite my integral. So now I can say this integral equals, this would be square root of u, so u to the 1/2. X to the 4th is just this crazy polynomial here, u minus 1 quantity squared. And then x dx, I forgot to write it too, is du over 2, or 1/2 du, and then bring that 1/2 down. Now everything is in terms of u, and what I would say at this point is go ahead and multiply out this guy, and then you have to distribute in your u to the 1/2. So this is probably the trickiest u substitution that there was on it. So you'd have to FOIL out the u minus 1, and then multiply that u to the 1/2. Let me go and bring up the answer to that so you can see what they're working for. Wrong one. So that's what's happening over here with all of our Usub stuff. All of this allowed us to substitute and rewrite in. So here's what we just talked about. Again, you would multiply out that u minus 1 squared, then distribute in your u to the 1/2, and then you can finally do your antiderivative of that. So you get some crazy thing. Now again, is it possible you will see this? Yes, without a doubt. Is it often that you will see this type of u substitution? No, not so much. But you will definitely encounter problems where you have to solve kind of for x and substitute that back in. Yes.
Well, you kept it in terms of u. Are we allowed to do that? Or will it be expressed?
Oh, no, that should be back in terms of x. No, you're right. Yep, that should say 1/7, and then throw back in your 1/7 squared. Thank you. Yeah, guys, make sure your answer is always back in the original variable that you had to work with. So let's even mess with this. 3x plus c. Good question. All right, I think the last one I want to take a look at was one on the back side. So one of our technicalities with that fundamental theorem of calculus is that the function needs to be continuous across those bounds in order for you to be able to do the definite integral. And if we take a look at this problem here, from 0 to 2, if I look at the function, we have that there is an issue with our domain. What value between 0 and 2 creates some type of issue with that function x cubed over square root of 1 minus 4, x to the 4th? Yeah, 1. If x is 1, then that would make a number. If x was 1, then x to the 4th would be 1. If 1 minus 1 is 0, that gives me a 0 in that denominator. What does that mean if we have that 0 in the denominator? Yeah, some type of asymptote. So if you think about it, so I don't know what my function looks like, but I know that at 1, there is some type of asymptote. Again, I have no idea what my function looks like. I'm just going to make it up here. I cannot find the area underneath the curve across here when there's an asymptote because it's forever and ever and ever going up there. So if there is an issue with my domain, then I cannot take the definite integral across that. So this one ended up being not continuous on these bounds, so we don't have an answer for it. We would literally say does not exist. Now, again, this is another type of thing that you won't often see. AP might throw a multiple choice question at you, in which this might happen. But so just when you're doing these problems, just do a mental check to make sure that these bounds that you're integrating over are okay within our function. Because again, if there's an issue in our domain, if there's a value within our bounds that causes our function to not be continuous, we cannot take the definite integral of that. Now, I was reading in the textbook a while back, you know, because you read textbooks for fun, right? When we have an indefinite integral, so if I were to just write the indefinite integral of this function, we do the indefinite integral with that understanding that it is not continuous at that value of 1 as well as -1. And so when we evaluate that antiderivative, again, we do that with the understanding that there are those two values that our function is not continuous over. So then when we can do our definite integral, we have to keep that in mind, consider that. Questions with that? Those are kind of weird ones. Are there others from the homework that we need to see? Okay.
Number 2.
Right here. This guy. Yeah. All right. So again, I would go ahead and rewrite this with negative exponents. So I have x to the -2nd, and this is 1 plus x to the -1st to the 1/2 dx. Now, if I take a look at this, there should be no issues with their denominator. All right. So then, again, identify what is your composition of functions. Here I can see that this is a function inside a function, so I'm going to go ahead and let u be that inside piece. So ud1 plus x to the negative first. So du is going to be negative 1 x to the negative second du. Sorry, dx. Okay, so then now taking a look at my integral. I have this piece taken care of with u. I have x to the negative second dx, but I need this negative here. So again, you could go ahead and divide by that negative 1. I can say that negative du equals x to the negative second dx, or you can multiply that. So now I can rewrite my integral. So I have, let's see, oh, we gotta change our bounds, so do that in just a moment. So our x to the negative second dx was just du. And this guy here was just u to the 1/2. Now, this is negative du. I'm going to go and bring that negative out in front. Okay, I need to rewrite my bounds. So I'm going to go and do u of 4 and u of 1. So let's see, u of 4, taking 4 and put it in 1 plus 1/4, so 5/4. And taking 1 and put it in 1 plus 1 is 2. So now my new bounds are 2 to 5/4. Again, you could go ahead and switch the bounds to make that positive, whichever you prefer. I'm going to do that. And then I have u to the 1/2 du. So my inside derivative here, my new exponent is going to be to the 3/2 multiplied by my reciprocal, evaluated from 5/2 to 2. And then we go ahead and evaluate from here. So we get 2/3, 2 to the 3/2, minus 2/3, 5/4 to the 3/2. You need to leave it at that. I don't think this one's simplified nicely. No, because we're doing square root of 2 and square root of 5/4. So I think, if I recall correctly, it's something like there's square root of 5 within there and square root of 2 within there. So you can simplify it really nicely. Other questions on the homework we want to see?
Okay, 2 over 6, I can get cut off.
Yeah. Answer is 9. Let me bring it back up for you though. Others that we have questions on? So aside from those weird ones that we had, how did we feel with our homework? I'm just going to tell us how we felt with U substitution. So I'm going to start here a little bit underneath. And again, those weird ones you will encounter. You will have some times where you need to substitute back in for x in terms of u, but it's not going to be every single problem. Yes?
How did you go from positive 1/2 to negative 1/2?
Because it was u to negative first divided by negative 1. So we just multiply the negative 1 times the 1/2 there. Because when I increase my power by 1 here, so I add 1, my new exponent's negative 1, I have to divide by that new exponent from negative 1. So 1/2 times negative 1 is negative. Other questions we have? Okay. Alright, so I want you to go ahead and try this following integral. Just wherever you have space, it's just one integral. I want to give you a chance to kind of deal with some of this weird algebra stuff that we did. Alright, so the integral of x times the square root of x minus 1 dx. So go ahead and give that a try. You will need to do u substitution. But go ahead and give that one a try again, keeping in mind some of those weird things we had to do with that homework. Feel free to work with one another on this. You can get this one figured out.
To be completely honest, you have no idea.
Distribute that so you can
That's
fast
you or you bring the x
minus one, so just
I don't know if you do the back substitution it's called. Back substitution. You once you find u, you find x. So it would be u plus 1 equals x. And you substitute
I didn't use any tricks on the before. That's why I was confused. You got
yeah, because right here you need to find just. So you would subtract, so you add the 1, so it's u plus x, so that's what you plug into this guy. So then here, because you need x, you just, you need to your x, so it's u one in terms of u, so it's u plus 1 x.
Yes.
So then you substitute that here. This is u plus 1, this is just u, this is u. When you're in these quadrans,
Yeah.
when you have like the power, you add.
Yes. Yeah. When you multiply like bases, you add the exponents. You plug it in, and then you FOIL for you distribute. Distribute, that's 1 plus, yeah. We're supposed to wait.
You would have to plug it in first, so it's u plus 1.
2 times x minus 1 divided by
And from here you distribute it just to make it simple. And then you add the
Alright, let's go and take a look at this. So again, this is one of those ones that requires some fancy algebraic footwork here. I see that my composition of functions is this guy here. It's a square root of x minus 1. And my inside piece is at x minus 1, so I want to choose that inside piece to be my u, as I've done here. And then my du ends up being dx, which when I look at this, I see that I have this taken care of by my u there, and dx is just du. But we have this pesky problem here of that x. And so again, we want to try doing something with that. I have that this u is written in terms of x, so let's go ahead and solve for x in terms of u. So adding 1 to both sides, x is just u plus 1. And then we now have something that we can substitute in for x. I can now take that and substitute it for x. So now when I do my integral here, instead of x, I have u plus 1, sealed in parentheses. And instead of square root of x minus 1, that is the square root of u, or u to the 1/2. And then dx was just u. Now from here, we do need to go ahead and distribute. So I have u to the, what's my new exponent here? 3. Good, 3/2. Plus u to the 1/2. Du.
Wait, if you multiply u times the derivative, isn't that just u?
I multiply u times the derivative.
I'm sorry, the square root. Like when you do u times u to the 1/2, isn't that just 1?
So when we multiply, we add our exponents together. Does that make sense? If it was square root of u times square root of u, that would just be u. Alright, so now I can go and integrate here. So my new exponent is the 5/2 multiplied by the reciprocal. And my new exponent here is the 3/2 multiplied by the reciprocal. And that allows me to write my final answer. So 2/5. And then my u was x minus 1 to the 5/2 plus 2/3. My exponent, or sorry, my u was x minus 1 to the 3/2 plus c. Raise your hand if you got this. Very good, very good. So again, this is dealing with that kind of what we call back substitution, where I let u be in terms of x, but then I substitute back in for x. So it's all interesting. All right, questions with that? Okay. So what we're going to do for the remainder of today is actually going to start working on our homework. Now your homework for tonight, you notice the stamp sheet says 3-7. So I have that for you, but what I'm also going to give you is that fake quiz. Next class is our review day before our test. And just like last unit, we'll have that second quiz instead of actually taking it for a grade. We'll just do it together, or we'll go over it together in class. So what I'm giving you is the already printed out version of it. I highly, highly, highly recommend that you go through and try this on your own. This is what would have been your second quiz if we would have done it. And so it gives the time limit on for each section and everything. I would highly recommend you go and set yourself a timer. Got 10 minutes and then knock it out. Try the next section, however long, knock it out. The key is up on Blackboard, just like before, and next class we will come back together and go over questions we still have on this, but that allows us to maximize our review day, going over questions on this and questions on our homework. So 3-7 is required, that's what I'll be checking for homework check, but I highly recommend we also work on that fake quiz. You might want to break it up. Do the multiple choice before Turkey, the free response after Turkey, or perhaps on Saturday when the effects of Turkey have worn off, because we're all going to be napping Thursday afternoon. But this, again, the quiz gives you exposure to AP-type problems you might see on the test, but then we have time to actually go over in class, and then you take it, I give it back to you, and then the next exercise. So I'm going to go ahead and pass out both. I want you to start working on 3-7 right now, and feel free to work individually, feel free to work with one another, feel free to move around the room to work with one another. If you would like to listen to music while working on this, that is fine, but if I see you on your phone for any other reason, phone goes away. Questions on that? So 3-7, definitely. Fake quiz, highly, highly, highly recommended. Again, feel free to talk to one another, interact with one another, but then just stare at that phone that you guys stare at all the other hours of the day. Socialize. It's weird to have to tell teenagers to socialize.